Hey, welcome back. We're in example 2 now, looking at the arccosine, and we want to find the arccosine of square root of 3 over 2. So remembering our acronym, all students take calculus. All of the trig functions are positive in quadrant 1. Cosine is also positive in quadrant 4. So we're looking for angles in quadrant 1 and in quadrant 4. So the reference angle is the angle that has an x-coordinate of root 3 over 2 in the first quadrant. And in degrees, that is a 30-degree reference angle. So 30 degrees in quadrant 1, if we reflect that into quadrant 4, where cosine is also positive, and it's 360 degrees for one full revolution around the circle, then this angle is 360 minus 30, which would be 330 degrees. So our two solutions to arccosine of root 3 over 2 are 30 degrees in the first quadrant and 330 degrees in the fourth quadrant. Next, in example B, we're looking for the arccosine of negative root 2 over 2, and cosine is negative in quadrants 2 and 3. And the cosine with a square root of 2 over 2 in quadrant 1, where our reference angles live, is pi over 4 reference angle. So we need to take that pi over 4 reference and get it into quadrants 2 and 3. So our reference angle, I'll just use a dashed line for that so we remember where it is. That's pi over 4. If I reflect that into the second quadrant, and half of the circle is 4 pi over 4, then subtracting the reference angle gets me into the second quadrant, and 4 pi over 4 minus pi over 4 is 3 pi over 4. Then to get into quadrant 3, we're going to start at half the circle, 4 pi over 4, and add the reference angle. 4 pi over 4 plus pi over 4 is 5 pi over 4. And that would be our third quadrant angle. So the two solutions to the arccosine of negative root 2 over 2 are 3 pi over 4 and 5 pi over 4. And then in problem C, the cosine of theta is the square root of 3 over 2. And it tells us that theta is in quadrant 4. And the reference angle that has an x-coordinate of root 3 over 2 in radians is pi over 6. So I have a pi over 6 reference in quadrant 1. And we want to reflect that into quadrant 4. And the whole circle, one revolution, would be 12 pi over 6. and subtracting our reference angle, 12 pi over 6 minus pi over 6 is 11 pi over 6. So theta is 11 pi over 6, and we're asked to evaluate the cotangent of theta, which would be the cotangent of 11 pi over 6. And cotangent is a quotient identity of cosine over sine. So we're going to take the x-coordinate at 11 pi over 6 and divide it by the y-coordinate at 11 pi over 6. That's cosine over sine. The coordinate in at 11 pi over 6 is a positive square root of 3 over 2 and a negative 1/2, because the x is positive in quadrant 4, but the y is negative. So we're going to take the cosine, the x-coordinate, root 3 over 2, divide that by negative 1/2, and dividing by a fraction means to multiply by the reciprocal. So we flip the second fraction, and we get negative square root of 3 when the 2's cancel. So you're going to go ahead and try this problem on your own, either on a whiteboard or scrap paper. The cosine of theta is 1/2. Theta is in quadrant 4. You're going to reason through the arccosine of 1/2 to find the quadrant 4 angle, and then the cosecant of that angle is what you're looking for. When you're ready to resume and check your answer, just turn the video back on. So the arccosine of 1/2 is 5 pi over 3. That's in quadrant 4, where the x-coordinate is positive 1/2, the y-coordinate is negative root 3 over 2, and the cosecant is 1 over the sine. So that's 1 divided by the y-coordinate, or the reciprocal of that y-coordinate. So we flip the negative root 3 over 2 upside down, rationalize the denominator, and that's negative 2 square root of 3 over 3.